Can you please go step back, go to the unit 1, introduction to chemistry? Yes.
Yeah, sure.
Uh-huh.
So it's the unit 1. And then we go to elements, compounds, and mixtures, or whichever one, right? Started. Oh, okay. Now I see it. So that's how
Okay.
you do it, because it shows you the video. Okay.
Yes, you can play the video, see what does it. Yes, play the video, see if it's
Okay.
useful or not. Yes.
Matter can exist as a pure substance, like an element or a compound, or it can be a mixture of more than one element or compound. The key difference here is that a compound is a combination of atoms of different elements to form a single molecule, where all the atoms are chemically bound. That's why it's a pure
Can you go
substance.
to like
Every
next
molecule is
step?
exactly the same.
What's up?
Go to the next step. Go down to see if it's going to take you back to question. Okay. And then you say continue.
Okay, continue. Oh, and there's
Now.
the question.
Now, can you answer better? Now, does it help you to answer the question?
Yeah, it'll help me answer the question.
Okay. Can you tell me what's the answer to that question?
Chicken noodle soup is an example of. No, I don't know. I didn't know it.
No, go ahead and say, what is the definition? Can anyone in class help? What is the definition? Okay. For homogeneous mixture, what's the definition? Anyone in class?
Homogeneous mixture.
What's the definition for homogeneous mixture?
A homogeneous mixture. It's a mixture in which the composition is uniform throughout the mixture.
Okay. So is it uniform when you look at the soup? Is it uniform?
Like, is it all the same?
Yes. Is it all the same? Like if you take your first spoon and second spoon, is guaranteed that you get the same thing in your mouth.
No,
No.
it's not.
Okay, so it's not homogeneous mixture. Is it a pure substance?
No, because it's like a bunch of things in the soup, right?
Is mixture, yes, it's a mixture. Is a pure substance is just one type of compound. It's not mixture of multiple. So it's
Okay.
not a pure substance. So is it a pure substance? Could be like element, okay? It could be
Okay.
element or compound. A compound is also a pure substance. So based on the definitions, if you did watch the video, then it would have tell you like when you have mixture, you have two different compounds. If it's heterogeneous mixture, you could see the components. So when you say chicken noodle soup, you see the chicken, you see the noodles, then you get the soup. So it's when you see different component, it's going to be heterogeneous mixture. So the video is going to help you with that. I want you to go to more instructions and watch the video and see the purpose of why we're watching that video before answering these questions. Just go down, please, for more instructions. See if you have one. Oh, it doesn't give you because is assuming that you already watched the entire video. Okay.
Yeah.
You can submit. Yes, you can submit and then.
There we go. Heterogeneous mixtures are not uniformly mixed on an atomic or molecular level. Okay, so the more instructions, and it'll help you out with the questions. You want me to stop sharing my screen?
No. Do you see that when you do that, then it would give you the explanation also, and it does explain why this answer is the answer, right?
Yeah.
Okay. If you did a question wrong, how would that? Can you do a question? Go to the next question. Continue.
Okay, continue.
Next question.
Homogeneous
mixture. Can anyone pick a wrong answer?
Okay, let me choose. Do not vary in mixture. That has to be wrong.
No, that's the right answer. That
Oh,
is
that was the right
answer. We're
one?
looking with that. We're looking for one thing that is not correct, right?
Mhm.
Homogeneous mixture varies from a heterogeneous mixtures in that a homogeneous mixture has property that do not vary, okay? Whereas in the mixture, suspended liquid dissolves a solute.
Yeah. And you said the first one was the right one, right?
The first one looks right. So
Yes.
pick the second one. Pick the
Vary in the
second one.
mixture.
It's going to hurt your grade, but you want to look at the more, okay. I want to go to the, okay. Yeah. A homogeneous mixture is different from homogeneous because it does.
Vary. Yeah, it does
Yes.
not vary in mixture. Okay.
Do not vary in the mixture.
So it
Because
explains
it's
it.
uniform. That's is the opposite to chicken noodle soup, because if you take the first spoon or second spoon of like salt water that you have, is going to be the same. Everything is going to be the same.
Okay. All right, cool. And it explains it down here.
Okay. So
Something
the
is a
more
compound.
instructions is going to be the one that it has the videos for you.
Okay, makes
For
sense.
each experiment. Okay. Any other questions? Let me look at the chat. Is just the responses, or these are your questions? Okay, these are responses. Okay, good. Any
Professor?
questions? Yes,
I have a question.
sure.
So I made an account on Newton and I was trying to log in and it kept saying that the URL isn't available. And then I tried emailing you through D2L and it said I was blocked. I couldn't email you.
Okay, now, how did you try to log in? Did you try to log in from the Newton assignment in D2L, or you tried external link?
It was
And-
the link that was posted on the welcome.
No,
letter.
no. I think last week we did talk about this, and I'm glad that you brought it up. For anyone who's trying to go to the assignments, please use the Ignacio. You can actually stop sharing.
Okay. All right. There we go.
Okay. Do you want to try it now and make sure that you can actually see log in to the I'm trying to see who was asking questions. It doesn't show. Your mic is off, right?
It's me, Sabrina.
Sabrina, go to the D2L, click on the Newton assignments and try to log in from the assignment itself. Just click on one of the assignments from the unit. Do you want me to make you host, or you want to try it yourself and let us know in a minute?
I'm doing it right now. 1 second.
Okay. If you want, I can make you co-host so we can see what you're doing incorrectly. Recording in progress.
Okay, I got it. I was able to.
Okay, perfect.
Thank you.
When I'm using a different device, it echoes. I have to do a couple things here. So make sure that I can, okay. Any other questions you might have?
Yeah, I have another question about
Yes.
the about quizzes and tests.
Mhm.
For the upcoming quizzes and tests, what's the best place to like study for it? For example, like the quiz that we have for the unit 1. Like, what's the best thing to study for that? Like, is it the PowerPoints, the worksheets, or the
Assignments. For
yeah,
the
the
quiz, assignments. Newton
Mhm.
assignments. If you finish the Newton assignments as soon as you can, then you take the quiz, then get ready for the test. For the test, you go back and review the assignments.
the
But
Newton assignments, right?
yes, the Newton assignments.
All
Yes.
right, and then your PowerPoints and all the other things you uploaded on D2L also help for the
They
test.
help you a lot with assignments. So basically, you can go watch the video, each video for more instructions from more instructions of each question, each single questions, or you can watch the video that I upload with the PowerPoint, and then you watch that as the, you know, as the review or understanding of the concept. When you understand the concept, it's going to make it fast for you to
Okay.
to answer the questions faster. Yes.
Makes sense. Okay. And last question, my bad, but for
That's okay.
for this week, we have to watch a video called What Chemists Need to Know. And it says it's located in Unit 1 Introduction, Supplemental Practice. Where would that be?
What is called? I'm sorry.
The video is called What Chemists Need to Know. It's under the course schedule
Okay, let
in
me
the
see.
syllabus.
Maybe I did not include that here, but I would tell you if there is anything that
Okay.
under the syllabus,
Yeah.
student toolbox. And was there a link or no link?
No link.
No link. And that's under assignments for unit 1.
I didn't find like a drop. I tried looking for the video, but I just couldn't
Let
find
me see where it says here. You said in the syllabus, right? The course schedule part?
Yeah, it says it
Read
in
the welcome letter, course syllabus, and additional items. Complete the quiz, student introduction discussions, and practice assignment. And then for under unit 1, it says complete Newton and view what chemists need to know.
yeah, that one.
Okay, I will find it and I will upload it. And it's not going to hurt your grade if you have not done it yet. But since it's here, I will find and I will upload it for you. Okay.
Okay. All right.
It's
Thank
not, yes, either I have to take it out of syllabus or I have to include that part of the practice. Okay.
you. Okay.
Unit,
Thank you.
wait, unit introduction. We don't have the unit introduction here. But
Okay.
I'm glad you bring this up because it's gonna, unit introduction. So you go to unit 1, under unit introduction. Okay, there is a link. It's there already. And the link is working. I can take you there, but I have to stop sharing that PowerPoint. Unit 1. Okay, if you go to unit 1, introduction. Okay, this is the unit 1, okay? Unit 1, and the first one is the introduction. Now, right here, it says under supplemental reading and practice, it says what chemist needs to know.
Oh, okay.
And you click on that, you would watch is a YouTube video, and it would be, something entertaining and good for you to know. Now,
Okay.
I don't know if it shows or not in your screen, but that's what the video is now. So was that clear on the syllabus, or was not clear that where to find it? I may have to change the verbiage there.
Yeah, I didn't know that it would be there, but now that you showed me, I know where to find it.
That's good. That's why we have these meetings. What chemist needs to know, located in Unit 1 introduction. So you look for Unit 1 introduction for that.
Okay, gotcha. Thank you.
You're welcome.
Yep.
Okay, any other questions before I go to a chapter?
I have a question.
Yes.
I came a little bit late and I still don't know where to find the Newton net.
Where to find it? Okay. What do you have on the screen still is the syllabus? Okay, so what you do, go to course content and you go to Unit 1. Unit 1, it says Newton coursework, okay? You go to Unit 1 and look for these, like the signs, that the binocular signs like this is the assignment for Newton. You click on it and it takes you to Newton. And that's the best way and the right way to access the Newton. So when you say launch in the new tab, it would take you to Newton. If you have the, did you purchase the access code or not yet?
I did.
Okay, when you purchase the access code, you just say launch in the new tab, it would take you directly to assignment.
Okay. Thank you.
Yes, first buy the Newton assignment and then go there. Or the first, if you don't have the Newton assignment, the first time you go in there, it would take you to purchase the Newton assignment, Newton access code.
Okay, thank you.
You're welcome. Any other questions, concerns, anything that I can help you before? Because these are, maybe it would set you in the right tone. So at least you know how to do the Newton assignments and making sure that you are using the more instructions part, because that's also very important. Okay, you don't have to buy the textbook. Thank you for answering. You just have to download it. The link is in the syllabus. Okay, other concerns in the chat? Newton access code, yes, you need to purchase the Newton access code. The 14 days, make sure you purchase before the 14-day expires. Not the textbook. The access code, I think it's like $39 for the semester. Perfect. Okay, chapter 1. This is a PowerPoint, is a very long PowerPoint, but I try to go over as much possible. Okay, it's the about the chapter 1 study of a change or definition for chemistry. What is chemistry? A study of the matter and changes that the matter undergoes. Matter, anything occupies a space and mass. So when you talk about a substance, these are the terminology that sometimes is used interchangeably, but when you are taking chemistry class, you must know the definition for each one specifically. And one falls under category of the other one. Like when you say a pure substance, then you say element, compound. Any of the pure compound or element can be classified as pure substance. But when you say pure substance, you don't mean exactly element, because pure substance covers more than element. It could be element, or it could be a compound. So when we classify the compounds, the substances in two major categories. One is pure substance, the other one is mixture. A pure substance, it could be just element. Anything you take from periodic table is element. So you have zinc, you have aluminum, you have copper, you have sodium, you have potassium, is pure substance. Compound is a combination of the two, but you have like, it has a fixed composition, okay? A fixed composition, H2O. Any drop of the water you take is made of H2O, 2 hydrogen per every 1 oxygen, is a fixed composition. When it comes to mixture is a combination of 2 or more of pure substances. This could be like an element plus compound, a compound plus compound, or maybe more than 2 is a mixture. So it doesn't have a fixed composition. Composition can be different. Composition, it would be, you have a homogeneous mixture. Homogeneous mixture, you could have 10% is a uniform. Okay, so it could have 10% sodium chloride solution, or it could have 15% sodium chloride solution. So if you have those still in the homogeneous, that means the particles do not show. You can't identify the components of the mixture, and is like evenly distributed throughout the mixture. That's called homogeneous mixture. The other name for homogeneous mixture is solution. Okay, heterogeneous mixture is a mixture of 2 or more pure substances that the composition is not uniform throughout. Like when you have a garden salad. When you have garden salad or you have chicken noodle soup, you could see different components. Okay, you could see different components. There are 2 things that I want to ask. I want to make sure that you can hear me, and second, know that it's being recorded. Okay. Mixtures can be separated by physical means. Like if you have mixture of sulfur and iron, you can use like a magnet to separate them. But if you have salt and water, you could do like distillation. You evaporate the water, you condense the water again, and then you collect the water. The salt would stay behind in the flask. That's like, again, is a physical mean that you can separate mixtures. When it's a pure substance, you cannot separate it into elements by physical means. You have to do like a chemical reaction to separate them. So we talked about already elements. Elements cannot be separated by, to simpler substances even by chemical means, because then it doesn't represent element anymore. So if you have, let's say, sodium, sodium has 11 protons, it has 11 electrons, and it has 12 neutrons. Okay, protons and neutrons, they are in the center or the nucleus, and the electrons, they orbit around the nucleus in different energy level. Level 1 takes like 2 electrons, level 2 takes 8 electrons, level 3 takes 1 electron. So if you try to cut sodium into smaller atoms, like smaller substances, is not going to be sodium anymore. Because when you say sodium with no charge on it, or sodium 23, which is the mass of sodium, it must have 11 protons and 11 electrons and 12 neutrons. So you cannot cut them into smaller pieces because it does not represent sodium anymore. If you have something with 6 protons, it's going to be carbon, not sodium. So a periodic table represents all or contains all the elements, and any newly found or discovered or synthesized element is going to be added to the periodic table in future. So the number of the elements that has been identified, sometimes you look at the bottom of the periodic table, there are some elements with no name. That means that the name has not been approved. The new element has been synthesized and has been proposed, but has not been named yet. So elements that 83 elements, they occur naturally. What happens to the rest of the elements? Elements with the atomic number higher than like 83, they have been created in the lab. Okay, so they are like kind of man-made, but they are stable enough.
Professor,
Yes,
are these PowerPoints on D2L?
they are not, but I'm going to add them to the D12. Yes, they were
Okay,
not.
thank you.
Yes, up to now. So then we talked about the compound, and compound is a substance that is composed of 2 or more elements. We also talked about last class. And if you have a compound, the composition is going to be fixed. You cannot change it. That means when you say H2O water, and now you say H2O2, it's not water anymore. You change the composition. This is a new compound. This is hydrogen peroxide. Hydrogen peroxide is not edible. Hydrogen peroxide is toxic. You cannot drink it. Okay, but water is safe. Universal solvent. It's H2O. H2O2 is going to be different. Same thing for CO and CO2. These are 2 different compounds. So each compound has a fixed composition. CO2 is inert gas. CO2 is okay to breathe. It's good for plants. It's safe for human. Not too much of it. That would cause like global warming, but it's not going to kill you. But CO and the other side, CO is not good. CO will damage your brain. CO is not safe. CO is toxic. So the composition of the compound is fixed, and each one has a separate name. You have carbon monoxide, carbon dioxide. So those are compounds, combination of 2 different elements. When you write a compound, you see if you write capital C, capital O, this is carbon monoxide. You write capital C and you write lowercase o, this is cobalt. So elements in the periodic table, they are shown by 1 or 2 letter. If it's 2 letter, the second one must be lowercase. If it's 1 letter, of course, always is capital. Okay, this table shows the summary of classification of the substance or the matter. Matter can be mixture, or it could be pure substance. Pure substance, it can be element or it can be compound, but mixtures could be homogeneous or heterogeneous mixture. The state of the matter is also presented in chapter 1 about the gas, liquid, solid. How can you change solid to liquid or gas? You have to increase the temperature, or you have to heat. Okay, when you heat up, you see the chemicals or the substance in the solid phase. They are in the rigid position. They are fixed position. They are not moving at all, and they are like frozen there. When you heat it up, you give enough energy to these molecules to kind of vibrate, to move around, and when they do move around, they become liquid. They are more flexible. They are now in the liquid phase, but they are still in a state that the volume is fixed. The shape is not fixed anymore, because for solid the shape is fixed, a definite shape and definite volume. When it comes to liquid, you have definite volume, but it's not definite shape. If you pour water into glass, it would take the shape of the glass. You pour it in the bottle, it would take the shape of the bottle. So the reason for that being flexible in shape is the space that you have between the molecules. It gives flexibility. When it comes to gas, they are moving constantly in a straight, the constant motion, straight direction. So they keep moving, and if they hit the wall, they go back and straight somewhere else. They are not wiggling, they are not waving, they're just moving straight in different direction. Okay, but gas molecules, they have a lot more energy. That's why if you want to change a liquid to gas, you have to give more heat in order to change it to gas, and the heat that you're applying is going to be saved as kinetic energy in this molecule. And when they gain enough kinetic energy to behave like gas, that means they must have in constant motion, then they are going to behave like gas, and the state changes to gas. So liquid changes to vapor, or it goes to gas phase. Any questions? Okay. A physical, the changes, physical change or chemical change, there are four terms or definitions that you want to know about. One is like physical change. Physical change is change like in state or making like solution or anything that does not change composition of the compound. Like if you change ice to water, still is H2O. You change water to water vapor, still is H2O. But if you electrolyze water and you change to hydrogen and oxygen, that is a chemical change. In a chemical change, composition of the compound is going to change, and the nature of the compound before change, after change is going to be different. The chemical formula is going to be different. So anything that is reversible is going to be physical change. That's another indication. For chemical change is not reversible. By physical means is not reversible. Like ice going to liquid water, if you freeze it, it goes back to ice. That's what I mean by the changes. And then physical property, if it's not covered here, I just have to add that. Physical property, those are properties that you can measure them in the lab, or you can feel it or see it using your senses. So if you say a metal like copper metal is shiny, that's something you can see. That's a physical property. If you have a liquid like water and you can measure density, that's physical property. You can measure melting point, that's physical property. When you measure melting point of ice, you don't have to change the composition of the ice to change it, the melting point, to measure the melting point. So that's physical property. You can measure it without changing composition. For chemical property, those are properties that it's indicated or it's obvious or observed when the compound goes through a chemical reaction. For example, if you say water boils at 100 degrees Celsius, that's the boiling point for water, that is physical property, okay? But when you say sodium reacts with chlorine to give sodium chloride, this is a chemical property. Sodium undergoes a chemical reaction to give sodium chloride. Chlorine can react with sodium to give sodium chloride. So that is a chemical property, physical property. And in order to measure this, you have to make sodium to react with chlorine and see if it's going to react or not. So chemical property in that sense is different from physical. Like mass is a physical property. You can measure it using a scale. You can measure. So there are some units, some other definitions, and the units that for measurements that they are indicated as a SI units. And then you have like the other units that are like English units. So first of all, we are looking for the physical property that you want to measure. What is mass? Definition for mass is that mass is, it shows or measure of quantity of the matter. So if you have an object that is 0.5 kilogram, that means there are the quantity or the amount of the matter that you have in that is 0.5 kilogram. So it indicates how much of the matter is included in that. Mass of a substance, it also shows how packed the particles are and how heavy the atoms are. Like if you get like a block of aluminum with the same dimensions, you get a block of iron. Iron is going to be heavier than the aluminum because iron has higher density. The iron has higher density, that means the atom, each atom of iron weighs higher than the atom of aluminum. So it's either that or is like more packed. Like when you look at like a plastic, compare that to a sponge is not packed. And because it's not packed, it's not heavy. But the molecules could be, like if you go to the molecular level. So what is affecting the mass, it's the mass of the atom that makes that compound or the matter, and also how packed it is. So those are kind of two factors, but the major one is the mass of the atom, or what is made of. If something is made of lead, of course, it's going to weigh heavier than something is made of zinc. Because when you look at the periodic table, atomic mass for lead is much higher than atomic mass for aluminum, or atomic mass for even for zinc. But definition for weight is the gravitational force. That is how much force is applied to the object by the gravity. So the gravity, it depends on the like the elevation or the gravitational force where you live, where you are making the measurement. If you are making measurement at the surface of the earth or on the moon, so it's going to be different. SI base unit, the base quantity, these are the ones that you need to be familiar. Like for length, you use different units. You use centimeter, you use millimeter, those are the sub units. You use yard, you use feet, and all other units that could be used for the mile, that could be used for length. But when it's mentioned about the SI unit, there's only one unit, and that is the meter, with its like subunits or with the prefixes for the SI units. Mass is kilogram, time is second, current is ampere, and then the amount of the substance is actually mole. Okay? And temperature is going to be Kelvin. You know, you don't use much of the current or the luminous intensity in chemistry, but those are also the base quantity that they have the 7 of them, the 7 units, they are known as SI units, or International System of the Measurement. Basically, is the agreement among all scientists that they use these, and since other units are used different places, then you have to be able to do some conversions. The prefixes that are used for any units, you need to be familiar with them. You know, up to ones that we actually are using, we definitely need to know the centi, milli, deci, kilo, mega, and micro. Nano, you know, these days, yes, nanoparticles, and then giga will, you know, as the more advanced you want in your technology, then you need to know mega and giga and all that. Now tera, because the hard drives that we're getting at least is like terabytes. But the ones that are used for calculations is going to be centi, milli, kilo, and deci. They are more often for the only for wavelength, we use like a micro and nanometers. SI unit for volume is volume is like the SI unit derived from the SI units that we have, the 7. Basically, cubic meter is not in the table of the 7, but since when you measure the volume is like how much, what's the capacity, then you get you multiply the length by width by height, and it would be like meter times meter times meter, and that is a meter cubed. So is a derived unit. A unit for density is the derived unit, is not a direct unit. We don't have like a gram per centimeter, for example, in the or kilogram per cubic meter. We don't have that in the table for the SI units, but density is
is a SI derived unit because the components are coming from that table, kilogram and meter. So based on definition, density is mass over volume. The unit for density would be then the unit for mass divided by unit by volume. So if you're looking for liquid is going to be gram per milliliter. If it's solid, for solid is going to be gram per cubic centimeter, because volume for solid is expressed in cubic meter or cubic centimeter. But for gas, the unit for density is going to be gram per liter. And why does it have to be gram per liter for gas? Because gas is very light. So if you take like 1 milliliter of the gas, this number is going to be very small. And since in science, we want to work with like workable numbers that they make sense, we don't have to use too many zeros, then instead of using your milliliter, they decided to use liter. So when you say density for air, let's say if it's like 1.2, that means 1 liter of air weighs like 1 gram. And that was a hypothetical number, but it's a very small number, even for like 1 liter, it's going to be small. The application, so when you talk about density, there are 2 things that comes in mind. First of all, you need to be able to calculate density. What is density? You measure the mass, you measure volume, and you do the math, you find the density. What's the purpose of using density is like to identify compound. That's one. Second, if you know the density, you have the volume, you can calculate mass. So any of these 3, any 2 of them you have, you can find the third one. If you have mass and volume, you can find density. If you have density and mass, you can find volume. So like it's more practical to know the volume of antibiotic rather than the mass, because if you know the volume of antibiotic, you just use a syringe and you measure. Otherwise, you have to have a scale in your kitchen in order to be able to say how much of that is going to contain the 5 milligram of antibiotic that you need. So sometimes it's you know, for the convenience, you would use volume versus the mass, and vice versa. But there are applications for identification of the compound. Let's say you get density for a compound for a piece of wood, and the argument is this, like piece of mahogany, is this from Honduras or is this from Spain? Apparently they have different prices. So you want to find out if this piece of mahogany is coming from Honduras or from Spain. What would you do? You measure the density, and the density of the wood or mahogany is coming from Spain is different from the density one coming from Honduras. Then you know, and you can prove that, yes, this is the right or wrong statement that they're making. So if you have a piece of jewelry that is claimed to be gold, then you know that if you know the density for gold, you measure the density of the piece of jewelry, then you can deny or accept the claim. So there would be, those are some application for density. When you have density, like 1 gram per milliliter for water, what does it mean? What does 1 gram per milliliter means? Or for, let's say, mercury, if you have 13.7 gram per milliliter, what does it mean? Any response? You can hear me, right?
Wait, what's the question again, Professor?
The question is, what does it mean if the density is 1 gram per milliliter? What does it mean in simpler word? Density is 1 gram per milliliter. What does it mean?
The water is pure.
If you find the density and is 1, that means water is pure. But what does 1 gram per milliliter means? It's so simple that even the question doesn't make sense, right?
1 gram equals 1 milliliter.
Every milliliter of water weighs 1 gram. So you can use this as conversion factors. So if you have 100 milliliter of water, and how much would be the mass, how many grams is going to be, you can use this as the conversion factor. And you start with like 100 milliliter and you multiply by 1 gram over 1 milliliter, because you can use this, you have the equation, you can use the equality, and you can say 1 gram per over 1 milliliter, or 1 milliliter over 1 gram. And which one do you need to use? You want to cancel milliliters, so you're using this one. I'm sorry, this one. And because you want to cancel the milliliter, and you do the multiplication, and that would be 100 gram. Or since you are smart and you know that water has a density of 1 gram per milliliter, if you have 100 milliliter, it's going to be 100 grams. So is like to find the mass or the volume if you have the density. Okay. Is downloading a software. I hope you don't see that in there. Okay. Temperature. There are 3 units in the for measurement for the temperature. Kelvin is the SI unit, and Celsius and Fahrenheit. The thermometer or the design of the thermometer or the scale, it's all based on boiling point of and freezing point of water. So the temperature that water freezes is going to be the same for all of them. The temperature that water boils is going to be the same for all of them, but the numerical value was presented to be different number. Fahrenheit said that water freezes at 32 degrees Celsius, Fahrenheit, and boils at 212 Fahrenheit. Freezing point or melting point, and then boiling point of water. Celsius graduated the thermometer based on freezing point at 0 and the boiling point at 100, and for Kelvin it was 273 for the freezing point, 373 for the boiling point. So you see that for the Celsius and Kelvin, the difference here is 100 units and 100 units here. The only difference is that the base unit is different. So if you have 0 degrees Celsius equals 273, 10 degrees is going to be 273 plus 10. So you only add 273 to Celsius to change to Kelvin. Or if you have Kelvin, you subtract 273 to get to Celsius. But when it comes to Fahrenheit, this space here is divided by 180. And because it's 180, each unit is not equal to unit of Celsius. Basically, for Fahrenheit, these are like smaller magnitude. So you have to basically use this ratio. If you have the Celsius, you want to convert to Fahrenheit, you need to multiply by 180 over 100, which is simplified to 9 over 5. And if you simplify that, is actually 1.8. So either one of these ratios you see is correct. 9 over 5, 1.8, or 180 over 100. You multiply the Celsius by 1.8 or 9 over 5, and then you add 32. Multiplication comes before the addition. And how would you check these numbers to be correct is like, if you have Celsius converting to Fahrenheit, the final answer should be actually greater number, because boiling point for water is 212, but is only 100 degrees Celsius. So you have to use a formula, a conversion factor, a ratio to go from Celsius to Fahrenheit or Fahrenheit to Celsius. But between Celsius and Kelvin, you're just adding the 273, and to be exact is 273.15. So if you have a Fahrenheit, you want to go to Celsius, your final answer should be lower than, the final answer should be lower than 172. So if you follow the formula, you want to go from, this was the equations that you had for going from Celsius to Fahrenheit. If you rearrange it, you can go from, Fahrenheit to Celsius. So from Fahrenheit to Celsius, you are going to subtract first 32 and then multiply by 5/9, or you are basically dividing by 1.8. But if you know one formula, you can just, substitute and do the math part by rearranging the formula. Is not too complicated. Just make sure that if you're going from Fahrenheit to Celsius, the number is going to decrease. The numerical value is going to decrease. If it's from Celsius to Fahrenheit, the number is going to increase. If it's from Celsius to Kelvin, the number is going to increase by 273. Scientific notation. What's scientific notation? As I said earlier, scientists, they want more convenience and they want workable numbers. So they don't want to use numbers that they have this many number of points, okay, now a number of zeros or decimal places. So if you have very small number or very large number, they express in the form of scientific notation. The general formula for scientific notation is A times B to the power of, A times 10 to the power of Y, N times 10 to the power of N, either one of them. A is known as coefficient and Y is the power, okay? For standard scientific notation, A must be between 1 and 10, okay? But if it's not a standard, it could be lower than 1 or higher than 10. But for standard, this should actually say for standard scientific notation, N is between 1 and 10, is less than 10 and greater than 1. Any number that appears in the coefficient, in the N part or A part of this number is going to be significant, because you are going to also learn about significant. So if you have a number that is less than 0 or less than 1, you are going to see a negative exponent. If it is greater than 10, you would see positive exponent for the 10. So the exponent could be negative or it could be positive. When you are adding two numbers with the scientific notation, they must have same exponents. So first you convert one or the other in order to get same exponents, and then you add the base or coefficient and use one of the exponents. You cannot add if the exponents are not the same. Okay? Exponents must be the same before you add them. If you're using like an advanced calculator, yes, you can do that. But if you're using just manual addition, you want to make sure that the exponents are the same. So it's going to be simple. When you are multiplying, you multiply the coefficients and you add the exponents. If you are dividing, you divide the coefficients and you subtract the exponents. This you have learned from your math class, you've learned in prior science classes. I don't want to take too much of your time for this. And next topic is like significant figures. Do you have any questions so far before I talk about significant figures?
No
Questions? No questions? Okay. Significant figures, there are some rules about counting significant figures. And first rule is that any non-zero digit is significant. So if you have like a 1, 2, 3, that is going to be 3 significant figures. Any zero between two non-zero is going to be significant. So if you have a zero between two numbers, is going to be significant. If you have zeros to the left of a number, okay, zeros to the left of a number. So if you have 0.00123, these zeros are not significant. They're just a placeholder, and it shows the value of the number, but they are not significant. You still have like 3 significant figures. Everything, other rules, they are simple, and all of you know that. You know them. The only problem, or sometimes students are not very clear on that, is the place of zero. So if the zero is between two non-zero, is going to be significant. If the zero is to the left of a non-zero, if you don't have anything, any number before the decimal place, is going to be non-significant. If the zero is to the right of a non-zero, okay, if it's to the right of a non-zero, if you see the decimal place, then it's significant. So this becomes like 4 significant, and these are the 4 significant numbers. If they are to the left of a non-zero and there's no number before that, is not significant. But if it's to the right, you have to see, do you see the decimal place? If you don't see the decimal place and you have 0 to the right, is not going to be significant. You only have these numbers significant. Okay, so this is the only complication that you might have, or questions. I would so anything to the right, if you have the 0 to the right, you are looking for decimal place. Do you see decimal place? Then it's significant. You don't see the decimal place, is not significant. This 0, you see decimal place, so it's significant. This 0 is to the left of a number, so it's not significant. Some of the solved problems, so to just help you with when you have a scientific coefficient, scientific notation, only look for coefficient. You don't have to consider the exponents. Just anything that was significant, it would appear in the coefficient part. Any zeros, if you have 2 zeros between two non-zeros, then it's going to be significant. That's why you have 4 of them here. When you are adding or subtracting, okay, when you're adding or subtracting, you don't count number of significant figures. What you do, you count number of decimal places. So if this number has 3 decimal places, I underline the decimal places. I put the number of significant figures in parentheses. That's just me. And then this is 1 decimal place. So the number that you have on the final answer cannot have more than 1 decimal place. If you have a number with 1 decimal place, number with 3 decimal place, when you're adding, the final answer cannot have more than 1 decimal place. Same thing for subtraction. You have 2 decimal places, 4 decimal places, your final answer cannot have more than 2 decimal places. So what you do for the rest of them, you have to round it up or round it down. So let's say you want to keep only 1 decimal place and you look only at this number. You don't look at anything else, only at this number, 3. If it's less than 5, you drop it. That's it. It's after decimal point, you don't have to worry about it. But if it's more than 5, then you add 1. Okay. If it's more than 5 or it follows 5 by another number, then you add 1 to the previous one. Like in this case, you only need to keep the first 2. The next one, 6, is higher than 5. That's why you're adding 1 to 8, and then you have 0.79. When you multiply, you count the significant figures. First number has 3 significant figures. Second number has 1, 2, 3, 4, 5 significant figures. Your final answer cannot have more than 3 significant figures. So what you do, you count the 3 significant figures and you look at the first number after what you need to keep. If it's less than 5, just drop the rest, okay? Drop it. If it's more than 5, you add 1 to the previous one. 2 significant figure, 5 significant figure, only 2 significant figure is allowed. The difference between exact numbers, any definition is exact number. Like if you have 1 meter equals 100 centimeter, this one has unlimited significant figures, okay? That's definition, and that is exact, is based on definition. Exact numbers, they have unlimited significant figures. You find the exact numbers by counting, or is definition, and measured numbers, those are found by measurement. Okay. So 3, in this case, is like 3 numbers, so that's exact, but these are measurements. Another definition is accuracy and precision. Accuracy and precision, how accurate it is, that means how close the data are. This applies to result that you get from multiple trial of the same experiment. If multiple trial is going to give you same answer, very close answers, that's accurate. If you get, too far apart, is not accurate. Now, what does, I'm sorry, really sorry. Accuracy means how close is to the target value. So the first one. Precision is closeness to each other. So I looked at the time and I got distracted, so I mixed the two up, sorry. Accuracy means how close the measurements are to the target value. So in this case, measurements are close to the target value, so they are accurate. And if they are accurate, since they are close to one another also, is going to be also precise. Precision means that how close they are to each other. So this is precise, but is it accurate? Is this accurate?
No, it's not accurate.
It's not accurate because it's not close to the target value or true value. So if it's not close to the true value, it's not accurate. And these they are not close to target value, they are not close to one another, so it's not accurate and it's not precise. Any questions? The dimensional analysis is a method for calculation that you are starting with like an equation or equality, and you create conversion factors. So if you have 1 liter equals 1000 milliliter, your conversion factor A is going to be 1 liter over 1000 milliliter. And conversion factor B is 1000 milliliter over 1 liter. Then you are given a problem. You have a 1.63 liter and you want to convert that to milliliter. So first of all, you need to know this definition. 1 liter is 1000 milliliter. Be able to either mentally or manually on the paper extract 2 conversion factors. Your next step would be to decide which one are you going to use. Are you going to use A or you are going to use B? You always start with the given number. Make sure you will write the unit as well. So 1.63 liters, and you want to change it to milliliter. So you have to choose a conversion factor that is going to cancel the liter and ends up with milliliter. That's why you are using conversion factor B. So you decide based on are you using A or B, based on what do you want to cancel. Since you want to cancel liter, you would use B. And you multiply this by the 1000 milliliter over 1 liter. You do math, you have a number. You also do the same operation for the units or cancel the units and end up with the wanted unit. So the wanted unit is going to be in milliliter. When you have a combination, like a derived unit, like meter per second, and you want to go to miles per hour, how you're going to treat this number calculation, you are going to take one step at a time. Change the mile to, change the meter to mile first, or change the second to hour first, and then work on the other one. So if we know 1 mile is 1609 meter, so you want to change the meter to mile. So your conversion factor that you have here is 1609 meter over 1 mile, or 1 mile over 1609. What is given is in meter. Which one are you going to use? You want to use the one that is going to cancel the meter, right? Since if you want to cancel the meter, you have to use this conversion factor. You have two options, but you have to pick the right one. So you change the meter to mile. So you are done with changing meter to mile here because you cancel the meter. But you still have the seconds and you want to cancel the second. If you want to cancel the second, you have you can just go and say 1 hour equals 3600 seconds, or you can break it down to two easier to remember units. You say 1 minute is 60 and 1 hour is 60 minutes, and go stepwise. And that's how you convert the derived units. So you take one step at a time. Questions?
No.